Stripping down science. The Naked Scientist.
Hello, welcome to this week's Naked Scientist Science Question and Answer Extravaganza, and that's with me, Chris Smith, and also with Victoria Gill. Hello, Victoria.
Hello.
And also with Dave Ansell. Hi, Dave.
Hi there.
And now, coming up on this week's show, the easy way to stay slim. It turns out it's an extra hour in bed because researchers have found that sleep deprivation is linked to piling on the pounds, so if you spend a bit longer a kip, then you might lose some weight. Also, we'll be hearing how scientists have made a tiny ultrasound scanner that can produce 3D pictures from the inside of your brain, and also how researchers are making flies drunk to work out why some people are more susceptible to the effects of alcohol than others. And that's all on the way.
Also this week we'll be hearing about how new robotic cars look to make the ride into work much more enjoyable.
In your commute to work, you wouldn't have to be behind the wheel. You could be having a nap or checking your email or on the phone and doing that safely and trusting the vehicle to get you where you're going.
And in this week's Question of the Week, we'll be finding out what plants make of a moonlit night.
If the sun is shining on the moon late at night and it's a full moon, and the light's being reflected off the moon onto the plants at nighttime, do they photosynthesize the light?
And the answer to that's coming up, and it will definitely surprise you, so that's all on the way. It is, of course, our science phone-in this week, so if you'd like us to solve a scientific problem for you, and so far we're getting our teeth into what makes a mirage, and also why do cats' and dogs' eyes glow in the dark, then get in touch. You can email us, chris@thenakedscientist.com.
The Naked Scientist Podcast, powered by UK Fast, the UK's best hosting provider, on the web at ukfast.net.
Well, let's kick off with a look at some of this week's top science news stories, as we always do. And here's an excellent story about why you should eat, sleep and be skinny, not so much merry, because scientists over at the University of Michigan, this is Julie Lumeng and her colleagues, they've looked at 800 9-year-olds, and they found that if they spend more than 9 hours in bed at night, then paradoxically they're actually more likely to be slimmer than kids that get less sleep. Now, there's been a growing body of evidence, pardon the pun, that adults who don't sleep enough are more likely to turn into overweight adults later on in life. And no one knew whether the same was true for kids, and so what this group of researchers did was to recruit 800 9-year-olds, see how much sleep they got by asking mum. So this is a sort of maternal report story. And then they followed them up for the next 3 years, and it was really intriguing. If they got not more than 9 hours sleep a night, they were much less likely to turn into obese 12-year-olds. And for every extra hour that they spent in bed when they were 9 years old, they were 40% less likely to turn into obese 12-year-olds. And by the age of 12 years old, for every extra hour they spent in bed, they were 20% less likely to get too fat. So why should this be? Well, the researchers have got a number of theories. One of them is that if someone's not getting enough sleep, they're not going to feel very kind of motivated or active during the day because they're feeling tired and grumpy. And so they're much less likely to actually want to do anything. So they don't take exercise. That's one possibility. The other possibility that the researchers put forward is that if you are feeling really low because you're really tired out, some people compensate for their low mood by eating more. They use food as a sort of appetite and mood regulator, so that might be part of the reason. But there's also more evidence from adults now that there might be a hormonal aspect to this, because there's two hormones, one of them called leptin, and that comes from the Greek word meaning thin, and that's produced by fat tissue. And when you are full up and you've got lots of fat on your body, you have high levels of leptin, and this shuts down your appetite. But in people who don't get enough sleep, the levels of leptin can fall by 20 to 30%. And also there's a second hormone called ghrelin, which comes out of your stomach. And this one makes you feel hungry, but when you don't get enough sleep, the levels of that go up by 20 or 30%. So it looks like not getting enough sleep fiddles with your hormones, makes your body feel hungrier than it really is, and makes you overeat.
Could it be working sort of in the opposite direction? Because if you're the kind of person who plays lots of computer games and doesn't go out running around, you don't get very tired, so you then won't sleep as much.
That was what they aimed to prove with this study, because people said, exactly as you've just suggested, Dave, chicken or egg situation. Is it that people who just are likely to have the kind of lifestyle that makes them bigger just don't sleep as well? And that's what this study proved, that people who are already not taking enough sleep and were already were 9 years old and not fat, when they then followed them up for 3 years, they turned into people that did tend to put on the pounds. So it was more that it was the sleep rather than the behaviour that came first.
Okay, cool. Now, researchers have built a panoramic ultrasonic scanner that works from inside your body. Now, ultrasound scanners are normally used from outside your body looking in order to look at the famous one is looking at babies. They work by sending pulses of sound into your body and listening for the echoes, and then from that they can build up a picture. Now, the shorter the wavelength of this sound, the higher the frequency it is, the better the picture is, the better the resolution, the finer the detail is. The problem is that the shorter the wavelength, the less distance it will travel through your body. So if you want to look deep in, you don't get very good images. Now, the way they've avoided this in the past by putting the sensor into a little probe and kind of putting it up a blood vessel so you can get good pictures from inside of the brain and see whether there's any damage from strokes or something like that. The problem is that the sensors could only so far look in one direction, so you've got a very, very limited view and you can't really work out what's happening. But Jingquan Chen and colleagues from New Mexico University may have the solution. They've basically made a little sensor and they've folded it into a hexagonal box so it can look it straight forward and in 6 directions sideways. So you now get a three-dimensional panoramic picture from inside the patient in really good detail.
How far away from the sensor can you see? Because I'm just thinking you wouldn't want to thread that too far into the brain because, of course, the blood vessels are delicate and you wouldn't want to puncture them or something. So how big is this? How far into the brain can it get, and can it give you pictures very far away from where it ends up?
I mean, it's a millimetre across, so you could probably get it through most reasonable-sized blood vessels. You're the medic, you probably know about this more than me. But I'm guessing it's probably got a good range of a few inches, so it's probably for close-in, high-detail stuff, not for looking at a whole brain at once.
Why do they think this is better, Dave, than other technologies? Because we've got really good ways of looking into the brain, MRI and CT and stuff. Why is this good?
I mean, a lot of the good features of ultrasound is that it's very cheap. It's using technology that you can... I mean, it's costing thousands of pounds, not millions of pounds, which is one big advantage. And you can see different things because you're looking at how your tissues transmit sound rather than how they transmit radio waves or X-rays. So it just gives you another way of looking at things.
I did also hear that scientists are really interested in using ultrasound to disrupt this structure, the blood-brain barrier, which keeps things that are in the blood system out of the brain, and that can include drugs. And so if you've got a certain bit of the brain that's diseased, then by zapping that part of the blood-brain barrier with ultrasound, you can temporarily open up holes in it so that drugs and things can get into just that bit of the brain. So maybe that would also be useful.
So you could really localise it with a little probe. Same sort of idea, maybe.
Well, from ultrasound to what's going on in the plant world, this sounds amazing.
Yeah, it's actually a piece of originally medical research that's taken on a bit of an agricultural bent. In last year, Andrew Fire and Craig Mello won the Nobel Prize for Physiology and Medicine for figuring out that you can take a little piece of RNA, which is like a template for a gene, and if you take a chunk of it that corresponds, that's a mirror image of a piece of RNA that codes for a specific gene, and put it into a cell, you can actually cancel it out. So you take your RNA that codes for the gene that you want to get rid of, so a disease-causing gene, something bad, and you can plug in your piece of RNA, put it into your cell, and your gene is silenced, and it's called RNA interference. And now 2 groups have taken this to help plants to sort of hijack the same mechanism and to help them prevent themselves from being attacked by pests.
How does that work?
So the first group, based in the US at Monsanto, a biotech group, have tackled corn rootworm, which apparently costs billions of dollars worth of damage in the US and eats corn plants, a big and very, very important food crop. So what they've done is they've found a gene that makes the rootworm grow, and without this gene, the rootworm can't grow. And they've developed a piece of RNA that silences this specific gene, and they've engineered the plant to produce this piece of RNA. So when your rootworm eats the corn, it can't grow anymore. Its gene is silenced.
It doesn't damage either us or the corn plant itself, presumably.
No, exactly. So it doesn't tackle any other pests, any other sort of wide variety of other creatures that might be living in the area around the corn plant.
Oh, right. So it's much better than these pesticides, which take down the good, the bad, and the ugly.
Yeah, exactly.
It should be fairly specific just to this one pest.
It's a specific piece of engineering that helps a plant to beat a specific pest that causes that plant a big problem.
That sounds really encouraging. The only danger, I suppose, is if the pests mutate or something, so they're no longer susceptible to the effect. But I guess we'll just have to wait and see.
Indeed, yeah, early stages, yeah.
Now, astronomers may have found the source of very high cosmic rays, which have been known as oh my god particles.
Oh my god, why?
That's it. Okay, cosmic rays are very high energy atomic or subatomic
Probably the
particles.
bigger discovery here, Dave, is that physicists have a sense of humour. I would think that.
I couldn't possibly
like
comment,
that.
Chris. Anyway, cosmic rays are these really high-energy subatomic particles like protons or neutrons, mainly protons or little helium nuclei, and they hit the Earth they're coming from space. In fact, there's several of them which are passing through you every second, but most of these are fairly low energy and come from the sun. Now, others come from outside the solar system and have more energy, and the more energy they have, the rarer they are. And until about 10 years ago, astronomers thought there was actually a limit on how much energy these particles could have, because they get slowed down by hitting photons from the cosmic microwave background radiation. And then they detected what they are calling these oh my god particles. One of these, with some subatomic particles, has a similar energy to a tennis ball moving at about 60 miles an hour.
But given this thing is smaller than an atom, that's a huge amount of energy for something so tiny.
Yeah, it's got the same amount of energy as a tennis ball, but it's 10,000 billion times lighter.
But what do we actually think these things are then?
Well, they think they are just protons or helium nuclei, and they've got this energy which is 100 million times more powerful than the most powerful than the particles you get in particle accelerators.
So they're pretty powerful. Where do they come from?
They think until now they don't know, but they've built a big detector in Chile, which is they've got lots of tanks of water, and they can detect the secondary particles. These particles hit the atmosphere and they produce a whole shower of more particles. It's the size of Paris, this detector they've built.
That's quite large. What's it made of?
Lots of tanks of water,
right.
Very pure water, and whenever one of these secondary particles hits them, it makes a little flash of light and they can detect them.
So it's underground then, this detector?
They're just underground, probably not too deep, because they're detecting not too high energy particles because they're the secondary ones.
Yeah.
And so they can see all these particles and they work out where they're coming from. And they seem to be coming from really, really large black holes at the centre of galaxies.
So how can things escape from a black hole? Because I thought the point of a black hole was that not even light can escape from a black hole. That's why it's black.
Virtually nothing, pretty much nothing can escape from the actual black hole. But when things are coming into the black hole, they get a huge amount of gravitational energy is released. And sometimes this can get released as very high energy particles. And some of these seem to get all the way to Earth, moving at almost the speed of light.
But we're still none the wiser as to what these actually do or what the point of them is.
Not really, but they were just so fascinating that there could be anything with that much energy.
There's a mystery solved that's been around for quite a long time, and now we actually know vaguely what they are.
Okay, so as you introduced at the beginning, a bit of a boozy story now, coming from another group in the US, actually. And they've catalogued all of the genes that are affected by exposure to alcohol. So they've written out a table of all of the genes that are seriously upregulated or downregulated by exposure to alcohol, and they've done this.
The idea being presumably that we can work out why people get sick and then who's at risk of booze-related problems.
Yeah, they think that this is a starting point for looking at genetic predisposition to alcoholism.
But this is in flies.
Yes.
So why is that relevant to me and you?
These particular flies, Drosophila, are just a very simple genetic model. They're very easy to sequence, so they're easy to study, but we do share quite a few genes in common with them. So often genetic studies start in these flies and then move on to humans.
They give us a clue as to what's going on in that.
Yeah, exactly.
So how do you possibly make a fly drunk and then work out how drunk it's feeling? Do they start talking very loudly and out of control and can't drive, that kind of stuff?
It's actually quite a human-like response. This is great. I love the experimental setup. They've invented a piece of apparatus called an inebriometer, which is like a little tiny fly
Student
pub.
union.
Yeah, exactly. It's a tube-shaped fly pub. So you have a long tube, and on the inside of your tube you have a lot of little shelves, and the shelves slant downwards towards the bottom of the tube. So the flies have to cling on to their little shelves to stay propped up. And you fill the tube with alcohol vapours to get your flies drunk enough so that they fall off the little perches. And you then eventually end up with a pile of drunk flies, the most sort of lightweight that fell off first at the bottom and the most hardcore drinkers further towards the top. So what they've done is they've separated off the most lightweight and the most hardcore binge drinking flies.
So that's like Glaswegian flies versus kind of Cambridge flies, I suppose, isn't it?
Yeah, exactly.
And what does this show?
Well, this in itself doesn't actually give them the results. What they've done is they've taken the flies from the very bottom, so the really, really lightweight flies, and they've bred them for about 25 generations. And the same with the flies at the very top, the most hardcore flies. And then they can genetically compare them. They can catalogue the genes from both groups of flies and find out which genes are affected.
And then you can find out whether you're a lightweight or not based on what Drosophila told you. Thanks very much, Victoria. This is The Naked Scientists with Dr. Chris, Dr. Dave and Dr. Vic. And we've already heard this week from Andy in Harwich about the story related to why people who sleep longer are thinner. Andy points out the most obvious reason is surely that people who are thinner simply are awake for less time than someone who's up for 18 hours a day who has more time to eat. Interesting thought.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
It is The Naked Scientists, and we thought that we'd do something a little bit special for kitchen science this week because this guy got in touch with me this week, and that's Bob. He's in Canada. Hi, Bob.
Hi.
Thank you for calling us up. You listen to The Naked Scientists in Canada?
Yes, I actually I love listening to it. I just was in a bit of a time warp, though, because I listened to a show yesterday, and it turned out to be your Christmas 2005 show. So I have a long ways to go before I'm caught up.
I thought the time difference between here and Canada was only about 5 hours, Bob.
Well, I guess maybe I'm just in warp time.
So anyway, what was the question you would like us to look at for you?
Well, in the work that I do, I'm quite often interrupted for 10 or 15 minutes to go do something, and then I get back to my desk. And inevitably, when I'm making my cup of tea, before I get finished, I'll be interrupted again. So my question is, I've made my tea, and I'm just about to put my cream into the tea, or my milk, and my question is, if I want my tea to be as hot as possible when I finally get to drink it, should I add the cream right away, or should I wait and add it just before I drink it? Which way will give me the hottest tea in the end?
Well, Bob, I plan to do an experiment today live in the studio and try and find out what is the answer to this question. So what I've got 3 identical mugs. And I've got a nice pot of tea, so I'm going to pour out tea into all these 3 mugs.
He has. I've never seen him use a teapot. Dave's normally so uncivilised, and it's actually got a really nice brew coming out.
So I'm going to try and pour about the same amount of tea into each cup, which will involve pouring some out of that one. So having a nice even amount of tea in each. Then good. One of them I'm going to add milk to now and stir it in nicely. The other one I'm going to wait until the end of the show, when I'm going to stir in some milk at the end. And the third one, I have a sneaky suspicion. What I'm going to do is I'm going to add some cream and just leave it on the surface. So I'll do that. I'll add some cream to one of them now.
Is this a cholesterol poisoning test on the side, Dave, or something?
Well, it keeps me amused.
Well, why are you doing this with the cream?
Well, I have a sneaky suspicion that if I can pour it onto the top and so it sits on the top, I might be able to act as an insulating layer on the top.
So the fat will float to the top. So you think cream... We're going to do wonders for people's arteries on this programme if they all start adding cream to their tea to try and keep it warmer.
Well, I apologise if I cause many people to die of heart disease.
Okay, so Dave is now adding equivalent amounts of milk and stuff to each of these things. So, Bob, are you impressed with the scientific technique being employed by Dr. Dave on The Naked Scientists?
Oh, it's a lot better than what I've been trying to do.
Well, look, we're going to now do this scientifically through the programme. If you would be so kind as to rejoin us at the end when we take the final temperature measurements, we'll tell you what you should do in your workplace with your cup of tea to make sure you have the warmest beverage.
That'll be great.
OK, thanks very much, Bob.
Okay,
you listen to us online as we go through, and we'll rejoin you in about 45 minutes or so.
That'll be great.
Thanks, Bob. Bob's in Canada, and he's come up with this week's Kitchen Science Experiment. If you've got a question that you'd like us to solve for you on The Naked Scientist, then get in touch with us. Email us, chris@thenakedscientist.com. Dave, how are you getting on?
I've got them all poured out. I'm going to give the one with the cream, which I'm going to mix in really well, give it a good stir. And I'm just going to leave them at the side and hope they get in. If anyone at home wants to have a go at this, that'd be great. So you can just, because the more experiments you do in a scientific experiment, that's better. So if you can get a few more data points, that'd be great. So if you've got a thermometer at home, do the same thing as I've done, or just with the tea, with the milk going in at the beginning or the end. Measure the temperature after half an hour or so and phone in with what you find. That'd be brilliant.
That number, 08459 25 2000. If you want to set up some teacups, make identical cups of tea, one with milk and one without, and then measure the temperature about 10 minutes after you make the tea, before putting the milk in the second cup, and tell us which one stays hotter.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientists.com.
And you're listening to The Naked Scientist. Nigel is in Wisbech. You're live on The Naked Scientist. Hi, Nigel.
Hello.
What do you want to talk to us about?
Right, my question was, why does a biscuit go soggy more quickly in a hot, milky drink than it does in a hot, watery drink?
Are you sure it definitely goes soggier quicker in the milky drink?
It certainly appears to, yes. If you put it in, it takes less time to go soggy in a milky drink than it does in a watery drink.
OK. This was actually the subject of a proper scientific study. It was done by Lem Fisher, and I think he's at the University of Bristol, isn't he? And he had sorry, Vic, you were going to say...
I think it was Nottingham, actually.
And he did this... He's got How to Dunk a Biscuit is actually the title of the book, isn't it? The reason why a biscuit goes soft when you dunk it in anything is because biscuits are largely made of starch molecules, that's the flour, and those are long chains of molecules, and in between them are sugar crystals, because there's a lot of sugar in the biscuit, that sticks them together, and some fat as well. When you put the biscuit in something hot, like hot tea, the heat from the tea melts the fat, and also the water soaks into the holes between the molecules and dissolves the sugar, and this makes the whole structure become very weak and limp, and the biscuit falls apart. And there's a certain sort of dunking time. I think rich tea, the dunking time is about 4 seconds, they calculated, but digestives are longer. They can tolerate up to 10 seconds of dunk before they start to fall apart. The only difference they found between milky tea and non-milky tea, if my memory serves me correctly, was the flavour. And they found that milky tea makes the biscuit flavour much more intense. Sounds a bit weird, why should that happen? But the answer probably is because milk has got a lot of fat in it, unless you're drinking liquid water, which is the white skim stuff, and the fat intensifies the fat-soluble flavours in the biscuit and helps them to evaporate and go up your nose, so you get more flavour and more retro aroma, as it's called, from a biscuit dumped in milky tea than one dumped in black tea. The only possible exception I can think is that perhaps the fat in the milk is helping to liquefy the fat in the biscuit a little bit faster. What do you think, Dave?
The other thing which I've thought is that in order to keep the fat suspended in milk, there are lots of things called surfactants, which act like washing up liquid in the way that it kind of can lift fat off you of washing up. And they might help, they reduce the surface tension of the water, so it could mean that the water can get into the biscuit quicker because it's got less surface tension. So it will get absorbed much quicker, so it will have more time to dissolve out the sugar.
Sounds like a good thought. Nigel, does that one clear that one up for you?
Sort of, yeah.
I guess that's another kitchen science experiment, isn't it?
Yeah.
Maybe next week.
Yeah.
All right, then. Thanks for joining us.
Okay.
And Douglas is in Southend. Hi, Douglas.
Hi there, Douglas speaking, yeah.
Welcome to The Naked Scientist. What can we do for you?
I've got a question, yeah. If we were able to build a spaceship now that was able to get to the universe where the Big Bang occurred, what would we find there now?
As in, you're assuming the Big Bang, we could find that point in the universe where the Big Bang happened?
Correct.
Because that's, unfortunately, just not possible.
Oh.
Yeah, as far as we know, the way we think that the universe is working is that the whole universe the Big Bang happened, but not only was everything close together, but space was smaller. So we say that the Big Bang was, the universe was really, really tiny, sort of maybe less than the size of an atom. Mm-hmm. That means all the space, it's not just all the particles are really close together, but all the space was much smaller as well. So in some senses, we are at the moment where the Big Bang happened.
Yeah.
Because the space has expanded, because this bit of space we're in now was at the Big Bang, it's just expanded hugely and everything's a lot further apart.
I understand. Thank you very much. I understand. Thanks very much.
That's all right, Douglas. It's quite pertinent, your call, because next week's programme will be coming partly from here in this country and also partly from Johannesburg in South Africa, live, and it's going to be a space science programme, and one of the people we're going to be talking to is actually someone who has just won a massive prize for discovering the expansion of the universe and the fact that as the universe expands more, it gets faster, so it's expanding more the older it gets. Ooh. And he's been looking at the evidence for that, so you can find out all about that on next week's show.
Thank you very much.
Thanks for joining us. If you'd like to join us on The Naked Scientist, you can email chris@thenakedscientist.com. Don't forget Dave's Kitchen Science Experiment, which is, Dave, just give us a little rundown on what you're doing over there.
Trying to find out whether it's better to put the milk in before you if you've got some tea and you're going to wait for 10 minutes, so it's better to put the milk in at the beginning or at the end in order to get your tea the hottest.
Victoria, I've got a question here for you. This is from Charlie, and he says, why do we have wisdom teeth I hear that it's a remnant of evolution. Is that correct? By the way, I love your programme. And I'm from Minneapolis, Minnesota.
Oh, that's very nice. Thank you very much. Yeah, as far as I understand it, that's the case. It's our ancestors needed wisdom teeth. They are, as many people will know through suffering, teeth that come in much later, so between the ages of about 18 and 25, and that's why they're called wisdom teeth, because you're older and wiser when you get them.
Allegedly.
Allegedly, indeed. But yeah, our ancestors, when they used to sort of eat raw meat and grub around and sort of eat lots of roughage straight from the tree and stuff, needed to they ground down their existing teeth. They had to sort of use very powerful jaws and chew a lot more. So they ground down their existing teeth and had a spare set of teeth that came in later on. But
although I've only got one, and it hasn't even come through.
Oh.
Yeah, I went to the dentist about 5 years ago, because I go about once every 5 years. Good like that. I've never had a filling in my life, and it's not because I don't go to the dentist. I put it down to living in one part of the UK with the most fluoride in the drinking water out of all parts of the UK.
So you're not advocating
and
people
I've
not
never had tooth decay, but I don't go. I also don't go to the dentist very often because I can't afford it largely. But, and he said, let's do an X-ray and see where your wisdom teeth are. And there was just one wisdom tooth, and I said to him, why do you think I've only got one? Because most faces are set up symmetrically, aren't they? What happens on one side usually happens on the other, hopefully, and doesn't seem to be the case in me. Don't have bilateral wisdom teeth, just this one. So there must be some kind of developmental thing. The cells that make that tooth didn't turn up in that bit of my jaw. But got an email here from Matt Eriksson, and he's actually listening in Stockholm, and he says, I listen to your programmes as often as I can, and I heard Chris say in one programme that we're using the energy at the moment per person of 3 Earths. And I've heard this before, so here's my question. How much energy does the Earth produce for a person to use every single day? Well, it's quite convenient that the Global Environmental Outlook, the GEO4 report, came out at the end of October, and this is a big multinational report where scientists get together from every country in the world, so there's no agenda to this. They just look at the raw data and work out where the Earth's going and how it's powering itself, if you like. And their current calculations show that the current environmental demand, in other words, how much land it takes to power each person here on Earth, is about, well, we're consuming resources equivalent to 22 hectares of land surface per person. Then you work out, well, how much can the Earth really sustainably supply in the long term? How much could we carry on? How long could we carry on doing it at that rate? The answer is Earth can only really support people sustainably on 15.7 hectares of land per person. So we're already using the land space per person of 2 Earths already, just in terms of land space, in terms of what we use for growing crops, fuel, that kind of thing. And if you look at fishing, this is really shocking. The amount of exploitation of the oceans is viewed to be 250% over what are taken to be sustainable levels of fishing in the long term.
And that really puts into perspective how much extra land we're going to need for biofuels as well. This is going to be an additional issue and lots more land use, so it's quite
correct.
Scary.
And the other point they make is that in about 40 years' time, they think that the Third World will need land space equivalent to the entire of South Africa for producing enough food just to support the extra people that the planet is sustaining by then.
Cool. I've also got a question for you here, Chris, from Chris in Northamptonshire. Could the retina be repaired using stem cell research?
That's a very good question. It's a pertinent question because in the last 12 months we've seen evidence that perhaps it can. The stumbling block at the moment is that we don't have the stem cells necessarily ethically that could do it. And why I say that is because scientists from University College London, about this time last year, published a paper in the journal Nature where they took mice that had been genetically programmed to develop a condition a bit like the human disease macular degeneration. And they took stem cells from newborn mice, the retina of newborn mice, and they implanted these stem cells into the eyes of the mice that had got this macular degeneration. And they were able to show that the mice got back their ability to see with these stem cells going into their eyes. And by following where the cells went in the eyes, they found that they migrated to the right part of the retina and turned back into photoreceptors, the kinds of cells that can take light and turn it into information that the brain can understand. So that's really encouraging.
Cool.
Got a quick one here for you, Dave. This is from Jason Paris, and he says, love your programme. I wonder if you can help me with this. While driving on a long stretch of highway, I noticed that when one looks ahead very far down the road and on curves, left, right, up, down, whatever, the surface of the road becomes almost reflective. I've noticed this under both sunny and cloudy conditions, but I'm wondering why it is.
This is the same thing as what causes a mirage. This is called a mirage, actually. What's going on is that it's on a hot day, so the road is getting really, really hot. So the air above it gets much hotter than the air above that. And this does something interesting with the light, because the less dense the air, because when the air gets hot, it expands. It becomes less dense. The less dense the air is, the faster light goes through it. So the light's going slower high up than really close to the road. And actually, what that means is the light comes in and it refracts, so it bends. So light coming down towards the road from the bright sky bends upwards and ends up going into your eye. So actually, what you're seeing is an image of the sky in front of you, but actually it's looking down. But what you see it when you look down on the road, which is why it looks reflective.
And when you look at, say, your toast cooking in your toaster, and you look at the air above a toaster or the air above your bonfire, it's all twisty and shimmery. Same phenomenon?
Yeah, it's the same phenomenon. You get sort of hot air in kind of big swirly patterns above the toaster, and that bends the light, which produces a distorted image behind.
Thanks very much, Dave. This is The Naked Scientists with Chris, Victoria and Dave. Coming up, we're going to be talking to Mark Peplow in a second to find out what's been happening in the world of chemistry. Very quick one here from James in Derby. He says, I heated up a non-vegetarian pizza the other day, and the bit in the middle wasn't particularly well cooked. How dangerous would it be to eat the pizza? Well, the answer is, James, you should always make sure things are thoroughly cooked, because the reason for doing that is that bacteria may have settled on the food when it was being prepared. They may have only been there at very, very low levels when the food was being prepared, but if it hasn't been stored very well, those bacteria can persist, and bacteria can easily survive the temperatures in your freezer, because bacteria can survive being frozen down to minus 200 degrees. They're very, very robust. So what then happens is, when you warm the food up, if you don't warm it up thoroughly all the way through to kill the bacteria, you get some bits of the food which are just warm enough to sustain a much better environment for the bacteria, so they grow really, really fast in those areas. And when they grow very fast, they can either infect you, like salmonella, or they can produce toxins into that bit of the food, like Staphylococcus aureus can produce a toxin which produces very, very powerful diarrhea and vomiting, and that toxin's also heat stable. So if you then thoroughly reheat the food, unfortunately, you can still get problems because the toxin's still in the food. So the moral of that story, I guess, is make sure you cook things absolutely thoroughly. Now it's time to take a look at the world of technology, and this month Chris Vallance is going to introduce us to the DARPA Urban Challenge. Now this is a competition that people develop cars that can drive themselves around town, and the final took place on November the 3rd, so recently, and the competing vehicles had to compete on a 60-mile journey. So they had to complete this journey obeying all the rules of the road and also avoiding the other drivers that were also on the road. Now, thankfully, this didn't happen on public roads because there were one or two mishaps. Instead, they used an urban military training facility that was in California, but it was a big success. And the reason they're trying to do this is to try and develop driverless vehicles that can be used in Iraq and other war zones. But there are likely to be, before very long, some other big spin-offs for the average driver like you and me.
Well, I'm obsessed with robot cars. It was the DARPA Urban Challenge. Now, the reason I like this is I saw the first challenge that DARPA did. DARPA is the Defence Advanced Research Projects Agency. It's, if you like, the brains trust of the US military. It's their kind of geek squad, if you like. They ponied up $2 million to see if somebody could produce a robot car that could drive around a simulation of an urban environment on its own. These aren't remote control cars. These are cars with computers on board, with laser scanners so they can see what's ahead of them, that intelligently drive themselves from point A to point B.
Have they had much success, Chris?
Well, yes, it was actually won. It was won by a Chevy Tahoe by the name of Boss, produced by a team from Carnegie Mellon University in Pittsburgh. So, I mean, that's quite a technological feat. Now, I remember back in 2005, they first tried this trick with what was called the DARPA Grand Challenge. That was out in the Mojave Desert. It actually took place next to a casino, Whiskey Pete's Casino. Absolutely nothing for miles around, dozens of teams trying to compete, and driving around the kind of desert terrain that I think if you or I had a go at driving it, we'd come a cropper in about 5 minutes. But these cars actually successfully drove around that track.
So what were the big kind of challenges that the people who are doing this work are trying to overcome then? Because it doesn't sound like rocket science to make a car follow a pre-programmed route.
Well, it's not pre-programmed. That's the thing. They have GPS waypoints. They know roughly where they've got to go, but there's not a pre-programmed route. They have to navigate obstacles for themselves. Now, in the first DARPA challenge, that was just navigating, rocks and bits of rough road, not driving off cliffs and not hitting bridges. In the latest challenge, the urban challenge that just happened last weekend, that they've actually had to navigate around other vehicles. They've had to actually sort of stay in the right lane in the road, deal with an urban environment, a much more, if you like, intellectually complex challenge.
Well, that's a whole new ballgame, isn't it? That sounds like the recipe for disaster. Were there any spectacular wipeouts?
Well, there was a spectacular wipeout. One of the really interesting vehicles from the Defence Agency's point of view is a vehicle called Terramax. It's a big truck. Tried to drive into a disused shop. So the cars do get confused. It's not a perfect science by any means, and it is quite a difficult computational and object detection problem that these teams have to face. If you look at these vehicles, you go up close to them, they are absolutely covered in scanners, these things called LiDARs, these laser detection systems, and radars, and all kinds of devices to help them figure out what's the road and what isn't. And if you think about an urban environment with other drivers around, that becomes really crucial.
So how do we think that this information that goes into making these cars be able to do this all on their own could be translated to making my life getting to work in Cambridge through a horrible rush hour a lot easier?
Well, funnily enough, the Defence Advanced Research Projects Agency are primarily interested in the military application of this stuff. If you think about a lot of the casualties in places like Iraq, they are people in convoys hit by improvised explosive devices, and there's actually a mandate from Congress for a certain number of US military vehicles to be robotic by a certain date. Now, in terms of the kind of cars that you or I drive, well, they are very keen to have this technology work its way into regular vehicles. This is Chris Urmson from the winning team from Carnegie Mellon University talking about how he sees some of this tech eventually working its way into the regular vehicles that you or I might drive.
The hope is that we would get to a point where you have a car that just won't crash. And so, you could always drive it if you want to, but if it detects that there's something going wrong, it might help you and prevent a collision. Or in the morning when in your commute to work, you wouldn't have to be behind the wheel. You could be having a nap or checking your email or on the phone and doing that safely and trusting the vehicle to get you where you're going.
So he's talking about avoiding crashes, Chris, but what about things like getting into tight parking spaces? Because we have a nightmare time when someone's parked and they've left just slightly bigger spaces than my car. I'm not brave enough to go into those spaces sometimes. Is technology able to help?
I think that's one of the things that we'll see this kind of technology really help with parking assist. There was a Japanese motor show very recently where we had all kinds of vehicles that could park themselves. That's definitely one of the priorities, I think, is parking. Yeah, who wants a ding on your car when you're trying to get into a tight space?
Who indeed, and we've already heard from Paula in Lowestoft. She says cars using sat-nav these days often get lost. Just look at that lorry that got jammed in a country lane for 3 days recently. She says, will we end up with robot cars driving around getting lost everywhere? Probably, is the answer to that one. Right, this is The Naked Scientist with Dr. Chris, with Dr. Dave and Dr. Vic, and in a second we're going to be talking to Mark Peplow. He's from Chemistry World at the Royal Society of Chemistry with an update on what's been happening in the chemical community lately. But before then, this week's Kitchen Science was a real live in-studio experiment because Bob phoned in from Canada and he wants to know, should he put his milk in his tea and then go off for his interruption in his tea break, or should he just make the tea and put the milk in when he comes back to get the hottest cuppa? So, Dave, you're doing the experiment. What have we found so far?
Well, so far, at the moment, the one where we put the milk in first and the one we didn't put any milk in yet, we're going to put in later, are neck and neck. They're exactly the same temperature, 52.5 degrees centigrade. And the one where I put the cream in very, very slowly near the end, that's at 51.5, so degrees centigrade lower. So could be interesting.
So we're already at the point where it looks like it's going to be worse to put the milk in second, doesn't it?
Yeah, even after only sort of 10 or 15 minutes. We've also had a phone call in from Barry from Peterborough. He says that Douglas Adams experimented to produce a perfect cup of tea. Everything must be hot. Always put the milk in first because the hot tea scalds the milk, giving it fuller flavour.
Well, there you go. Can't argue with a man who had the answer to life, the universe and everything.
OK, we've got a quick question for you, Chris, from Ben Hershey in Ohio in the US, who wants to know why dogs' eyes shine in car headlights and humans don't so much.
That's a brilliant question, and the answer is that if you look at the back of the eye in animals that go out at night, so nocturnal animals or animals that are likely to be hunted at night, they have this structure called a tapetum lucidum, which is Latin for bright carpet. And if you look at the back of their eyes, if you dissect a sheep's eyeball or something, you'll see this surface that looks like mother of pearl. And the back of the eyeball is highly reflective, like a mirror. The reason for having this is that if you're under low light conditions, light comes into the eye, the retina sticks out into the jelly-like stuff at the back of the eye, and any light that misses the retina would be soaked up by the back of the eyeball, so you wouldn't have a chance of seeing it. So by having the back of the eye being a bit reflective, then any light that missed the retina the first time can be bounced back onto the retina, and you have a second chance of seeing it. Now, the payoff is that you can see in low light. You can see things that you or I couldn't see so well in the dark, like a predator coming to get you. The downside is, of course, the light gets altered in its path very slightly, so the acuity, how well you can see, is lower if you have this structure. Dogs, cats, sheep, cows, horses, they all have it, and that's why if you shine a torch at a dog in the dark, its eyes look kind of alien, like they're glowing, a bit like Tony Blair on those posters that you saw about 10 years ago. That's why they have this tapetum lucidum. It's nothing to do with the pupil being open wider or smaller, although because it's dark the pupil will be open a bit wider, so you will see slightly brighter eyes in those individuals.
Got some questions here for you, Chris, as well. One from Dave in Ontario. He says, why is it that if you're going to cook two items the same size in a microwave, you've got to cook them for twice as long, and you have to do the same with a normal cooker? And also from Kevin, he wants to know if microwaves kill bacteria in food.
The answer to the first bit, why do you need to cook things for twice as long, is that when you put something in the microwave, it's getting hot because it's soaking up energy from the microwaves, which are flowing from one side of the microwave to the other. The microwaves make the molecules in the food vibrate, and that soaks up energy, that makes them hotter. That raises the temperature of the food. If you put twice as much stuff in the microwave, it's going to soak up twice as much of the energy out of the microwave, potentially, and therefore you're going to have to cook them for longer because you've not got as much energy to share just in one piece of food. You've got to share it with two. So that's why 2 big potatoes takes 12 minutes rather than just 6 minutes. In terms of microwaves killing bacteria, this is a really important point. It goes back to what James from Derby was saying about not when you don't heat something enough. If you don't heat food to the right extent, then there's a danger, especially in a microwave, and that's why you have turntables, of getting hot spots and cold spots. And if you don't get a hot enough area in the food, then any bugs that are in there could persist. So you could end up getting food poisoning. And the thing about microwaves is they're just radio waves. And the reason they make food cook is because they heat the food up, because the food absorbs the energy in the microwave, and this makes the molecules in the food vibrate a lot and raises its temperature. They're not doing anything special. They're not zapping the bugs like gamma irradiating them or something. They're not blasting apart their DNA. They're just heating them up. So if you don't make the food hot enough, then you're not actually going to kill anything. So it's all down to heat and nothing else. Now, a quick question here from Charles, and he says, why is it when I cut up apples into small pieces and put them in a microwave, close together they spark and flame up? And Kurt says almost the same thing. If you cut a grape in half and put the two bits next door to each other in the microwave, you get some incredible glowing lights. Why does that happen?
Okay, what's going on here is that microwaves themselves are a form of electromagnetic wave. When they hit something, they try and make an electric current flow in it. And if you've got two things, especially if you cut a grape almost in half and you leave a little bit of gap in, a little bit of skin holding them together, or you've got two things just about touching, there's going to produce a big current. You've got two big lumps, you get a big current running through this little tiny gap, the little kind of piece of skin in between. So it'll get hotter and hotter and hotter until eventually it's going to burn out. At this point, you've got these big electric currents trying to get between these two lumps of fruit. They're going to actually jump through the air and create a spark, which is what you see, the crazy sparking thing. And that will take the current and you'll get a fireworks display, pretty much.
Thank you, Dave. This is The Naked Scientist with Chris, Vic and Dave, and if you'd like to ask us any questions, you can email us, chris@thenakedscientist.com. On the way, Mark Peplow is from Chemistry World to bring us up to speed on what's been happening chemically speaking.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
It's Chris, Dave and Vic, and this is The Naked Scientist. Time now to catch up, as we do once a month, with Mark Peplow. He's from Chemistry World. Hi, Mark.
Hello, Chris.
So we were talking about microwaves just now, and now you're talking about a microwave oven which is absolutely excruciatingly tiny. That's absolutely right.
This week, American scientists said that they'd created what they're claiming is the world's smallest microwave oven.
How big?
It's shorter than an ant and half as wide as a single human hair. So it's a tiny thread of an oven. You could fit basically a pinhead drop's worth of liquid in it, about a millionth of a litre.
Well, people say ready meals are making the population too fat, so maybe we should just give everyone one of those microwaves because they get a microcalorie. But what's the point of this?
You wouldn't get much of your evening dinner in this. Essentially what this is for is to create a device where you could heat small amounts of material very easily and very quickly. A good example is actually if you were doing forensic work out in the field and you wanted to analyse some DNA. One of the ways that people do that is to use a reaction called the polymerase chain reaction, and that involves heating and cooling, and it basically amplifies your DNA sample so that you can do a test on it. If you imagine a handheld device, it needs some very small heating facility within it. And what these guys are proposing is that they can use this microwave oven, tiny as it is, to do this sort of analysis.
How does it actually work?
Well, essentially, it's very much like, in principle, very much like the microwave oven in your kitchen. You have a small cavity hollowed out of a polymer block where your sample goes in and small channels to deliver that liquid into the cavity. And you have a very fine tracery of gold wires etched into the polymer block. And it's the electrical current moving through those in a particular way that delivers the microwaves.
Sounds amazing, but sticking with the very small, also fuel cells are a hot topic at the moment.
Yeah, fuel cells are basically a way of turning chemical energy in, say, a gas like hydrogen into an electrical current. And researchers in Oxford, led by Fraser Armstrong, have created effectively a microscopic fuel cell. What they've done, they've taken a graphite particle. Graphite is just the stuff in your pencil, and they've stuck an enzyme on it that converts hydrogen into an electrical current. They've proved that this is working by, on the other end of the graphite particle, sticking another enzyme which does a chemical reaction. They're saying that this is a proof of principle that you can take these sorts of fuel cells, which are already being used in cars and lighthouses and things like that. You can also use them to run chemical reactions, again, in these microscopic test tubes that chemists are now working on, so-called labs on a chip.
And sort of application-wise, you would think people are quite eager to have ways of powering tiny robotic things that you could, say, put inside bodies or do very, very technical things at very tiny scales, but they need an energy source, so something like this must be very important for that.
That's right. Conventional batteries have proved incredibly difficult to miniaturise in that sense. Conventional battery technology just ends up making very bulky battery packs. Fuel cells are an alternative where you can really shrink things down. You have a tiny volume of gas that serves as an energy source like hydrogen, and this would be the converter to actually give you a constant current.
Thank you very much, Mark Peplow.
Thanks, Chris.
That's Mark Peplow. He's from the Royal Society of Chemistry, and he's the editor of Chemistry World magazine. They're on the web at chemistryworld.org.
And it's time now to catch up with Diana for a Moonlit question of the week.
Hello and welcome to Question of the Week on The Naked Scientist, where we'll be talking about the werewolves of the plant world.
Hi, my name is Pete Chirakis. I'm from Minneapolis, Minnesota. And I was out in the back one day, and I was wondering if the sun is shining on the moon late at night, and it's a full moon, and the light's being reflected off the moon onto the plants at nighttime. Do they photosynthesize the light? And if they do, can they survive only on that reflected light, or do they need direct sunlight?
Are plants 24-hour light eaters, or do they go to sleep at night?
I'm Howard Griffiths. I'm the Professor of Ecology at the University of Cambridge in the Department of Plant Sciences. When I was first thrown this question about the role of moonlight and photosynthesis, my initial response was not a chance, because the light intensity that we get reflected from the moon is an order of 100 to 1,000 times too little to support photosynthesis in most terrestrial crop plants and plants we have in our gardens. However, I did a little bit of digging around, and I looked at some latest analysis of photosynthesis rates in algae. And amazingly enough, it does seem that some groups of very small phytoplankton might be able to photosynthesize using the light from the moon, provided that it was in the tropics and provided that it wasn't being attenuated by a water column, which tends to absorb light exponentially. So the answer is still probably no, because obviously phytoplankton grow in a water column, so they're not really likely to be able to pick up the light intensity. However, it also opens up a number of intriguing questions, because plants do certainly try to avoid the light from the moon. I'm sure many of you are familiar with the folding of leaves that we see in the clover growing in our lawns, and lots of plants in the garden fold up their leaves at night. Darwin was interested in this and thought that it was to do with the leaves trying to maintain their heat balance at night. What we think is happening now is that the leaves are trying to avoid moonlight so as to prevent their circadian rhythms being disrupted by those very low light intensities, because they certainly do respond to moonlight. And in fact, it's now known that lots of animals as diverse as snakes and crocodiles and a whole array of plants and different systems, including humans, are highly sensitive to moonlight and the way that it can interrupt our circadian control and our sensing of day length.
So it seems that plants do close the fridge door at night after all. There simply isn't enough light from the moon for them to get down to sugar making. This is unless they happen to be a special sort of dry algae, which can't really exist anyway. Enough of listening to me babble on. Have a listen to this question.
Hi, this is Jim. I'm in Virginia in USA, and I have a question about loud noises and the damage they might do to hearing. I'd heard that tools like hammers that make short, loud noises are supposed to be more damaging to hearing than something that makes a long, continuous noise, and I just kind of like to get some confirmation on that.
And what about seeing more than just your holiday through a pair of sunglasses?
Hi, I'm Lauren calling from Australia, and I wanted to ask, how come when you wear polarized lenses can you see strange patterns of light in windows and shiny rainbows in metal?
If you've got an idea as to why some noises are worse than others, or why I might sing a rainbow with my sunglasses on, drop me a line to questionoftheweek@thenakedscientist.com, or have a look at our forum. That's all for this week's Question of the Week. Bye for now.
Well, thank you very much, Diana. It's Diana O'Carroll with this week's Question of the Week. And we also had a response from Paul FR at the Naked Scientist Forum. That's on the web at nakedscientist.com/forum. He hit the nail on the head with that question when he said the intensity of the light from the moon is too low for plants to use it for photosynthesis. But why do polarising lenses create rainbow patterns? And what's better for your ears, a hammer or a chainsaw? Not used on them, obviously. If you've got a thought on that, then do email us questionoftheweek@thenakedscientist.com.
The Naked Scientists. For more information, get online at nakedscientists.com.
And this is The Naked Scientists with Chris, Vic and Dave. If you'd like to join in tonight's programme, then you can email. It's chris@thenakedscientist.com. Bob's come back to us. He's actually listening in Canada because he came up with this week's Kitchen Science. Hi, Bob.
Hi.
Now, how's your tea doing? Have you made a cup of tea out there?
Actually, no, I'm not drinking this afternoon.
OK, well, Dave has done your experiment, so let's find out from Dave how it's going. Dave?
Well, I've set up the 3 mugs of tea. 2 of them have got cream in them. One of them I mixed it in well, and the other one I haven't. And there's one which I haven't added the cream to yet.
And the reason for leaving the cream unmixed was because you thought that it might have lots of fat on the surface, which would act a bit like a sort of insulating blanket on the top of the liquid and stop the heat loss.
That was my theory. I'm not entirely sure whether it's worked, but we'll find out. OK, so at the moment, the temperature of the one without the milk in it yet is 42.5 degrees centigrade. The one with the milk in, well mixed in, is about 43.5, and the one which I didn't mix in is still back to 42.5 degrees centigrade.
So unmixed, no milk in it yet, and it's still just about the same temperature as the one that was...
In fact, the one which I haven't put the milk in yet is actually lower temperature than the one which had the milk cream in to start with.
OK, so right, let's add the milk.
Add some cream in here. So I've got to measure to make sure that it's fair. I'm not cheating by putting.
Yeah, he's got a sort of egg cup, and he's adding. This is very creamy tea, but at least we know it's very, very rigorous science that's going on here. So
give that a good stir to make sure it's fair. And we've got to wait a little bit for the thermometer to react.
OK.
OK, so now adding the cream later, it's down to about 40.8 degrees centigrade. The one where we mix in well is at 43.5.
Cool, so we've got an answer to it. We can give Bob the answer to what he should do in his tea break, but why are we seeing this? What's the sort of science going on here?
Yeah, it worked pretty much as we'd expected, really. Well, adding the cream cools the drink down, but it doesn't really matter whether it's done at the beginning or the end of the process. It's going to have a similar sort of effect. Well, so what we're really interested in is the amount of heat that's lost through convection, conduction, evaporation, etc. All the ways the heat's going to get out of this cup. The more heat the tea loses, the cooler the tea's going to end up in the end. Now, hot tea loses heat quicker than the cold tea because the difference in temperature between it and the surroundings is going to be much bigger. So when we added the cream to the first cup, it spent about half an hour at a lower temperature than the second cup. So it's going to lose less heat than the cup which had the cream added afterwards. So once all the cream is added, the cup which had the cream added first is going to be warmer.
Right, so what this means for Bob is that, coming back to his tea break, he needs to make the tea and add the milk or cream at that point and then go off and do whatever the interruption demands. Because if he does that after the interruption, the tea will be, by definition, colder.
Yeah, that's right. And actually, it seems there's another effect going on, because the tea which we didn't have the cream in it, actually after half an hour, was colder than the tea which had the cream added in the beginning. So the cream seems to actually have an insulating effect as well.
What about the one that you did where you just put the cream in and layered it on the top, thinking it would have a sort of insulating effect? The fat would float to the top and this would stop the heat getting out. Has that worked?
I mean, there was a bit of an insulating effect, but it didn't seem to be any better than the one where I mixed it in. It's probably because the cream was actually denser than the tea, so it sank to the bottom, so it didn't produce a very good insulating layer.
Or is it just that most of the heat's being lost through the sides of the mug and the actual amount coming off the top isn't very big?
And there's going to be a lot of heat loss from the side, but I think the top's still going to be quite significant.
OK, well, thank you very much, Dave. So, Bob, there you go. You have your answer, tested here live on The Naked Scientist.
Oh, that's great.
OK, so it's scientifically proven on The Naked Scientist.
OK, well, I enjoy my tea almost as much as I enjoy The Naked Scientist.
Well, it's very kind of you to say so. Thanks for joining us, and thanks for a great idea for an experiment.
OK, bye-bye.
Cheers there. Bob Reed, and he's in Canada, listens to us on our podcast, which you can get from our website. That's nakedscientist.com/podcast. Now, Victoria, I've got an email here from Ash, who is an interesting lady. She says she's an Australian who's currently living and working in Shanghai. And she says, as we now move towards the colder winter months, more and more people around me are catching colds. And this has inspired me, if that's the correct word, to send in an email to ask the following. What's the correlation between cold weather and catching a cold? If our body's core temperature is controlled within such strict parameters, then does the ambient temperature affect internal conditions and health of our bodies? That kind of thing.
Well, yes, it does, because the ambient temperature makes it easier or less easy for your body to control the internal temperature. So you have to use a certain amount of energy to keep yourself at the right temperature, keep yourself healthy. This is more to do with how many bugs are around, really. Bugs, the cold virus and the flu virus are extremely infectious and airborne. So, but in the cold weather, if you have sort of vulnerable people who are getting sick because their immune systems are having to work a lot harder and not getting as much energy to them because they're having to try and keep themselves warm, then they get the bugs are around and they're transmitted and everyone comes down with it.
I guess there's also an effect that in the winter everyone's kind of cramped together inside, whereas in the summer they're spread out, so fewer of the viruses are going to get from one person to the next. They're not going to spread as quickly.
Yeah, exactly.
That's right. And the other big determinant that science has shown is really important to the spread of infections is the school year. And lots of people going away on holiday to their own part of the world, and then they come back and they all congregate in this thing called a school, which is really a viral mixing pot where everyone exchanges viruses and then takes them home to their parents and to their older brothers and sisters who take the things to their schools. And school terms are really important in determining who gets what. Now, Dave, this is really interesting. Quick question here from Joseph Blofeld. He says, why are bubbles round?
OK, that's because the bubble is made up of a very thin layer of water with soap molecules on the outside, and that has surface tension. And it's trying to get as small. It's trying to minimise its area. It's trying to get as small as possible, smallest surface as possible. And the best shape with the smallest surface for a certain volume of air inside is a sphere, so they're round.
Victoria, this is really hard. I hope you can do this. It's from Joe Flynn, and he says, I like listening to your podcast. Can you tell me what chemical compounds in insects make their guts so difficult to clean off the windshield of my motorbike?
I have absolutely no idea. I should have deferred to Mark on that one, I think. He's disappeared out the studio.
Sorry, Petro's just corrected me. It was Joseph in Blofeld. So sorry for calling you Joseph Blofeld. Sounds like the bloke in James Bond, the nasty person. Anyway, right, I think we're pretty much out of time. But I have to say, thank you very much to Victoria for... It was actually Victoria's first programme with us on The Naked Scientist. Thank you very much for doing a wonderful job and joining us. We've really enjoyed having you here.
Thank you for inviting me.
And thank you very much, Dave, for doing a great job,
Cheers.
as you always do. What a wonderful experiment. Well, that's pretty much it for this week. Thank you very much for listening. And, of course, don't forget you can catch up with all of this week's stories on our website at nakedscientist.com. And if you do have the chance, do please drop by our forum, where we could really use some serious scientists to help to answer some of the fantastic science questions that are coming in there. That's at nakedscientist.com/forum. Now, next week, very exciting, it's going to be a show from 2 different countries, from 2 different continents, in 2 different hemispheres, and that's because I'll be in Johannesburg, South Africa, and Dr. Katz will be here in Cambridge, England, and together we'll be exploring the science of space, including the expanding universe, the workings of one of the world's largest telescopes, and also how the human body copes in microgravity. Plus, we'll be analysing whatever this was that landed on one of our listeners.
I heard this ping and clatter, and I looked round, and I thought, I know what that must be, because it can't be anything else. A meteorite.
So was Colin really hit by something from outer space? Well, join us next time for the chemical verdict. Thank you very much to our production team, Ben Valsler, Mira Thillingham and Diane O'Carroll. Thank you for listening. See you next time. Goodbye.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.